This is a Math 1010 video going over Module 1.1. Okay, so first we're talking about graphs, functions, and linear equations. So axis is the number line used to locate a point in a plane. Now the rectangular Cartesian coordinate system, two perpendicular axes that we label x and y axis. So these pictures right here represent rectangular or Cartesian coordinate systems. A lot of times you might just think of them as a graph. So we have our y-axis is up here. Notice the y on top, so y-axis, and the x-axis is over here. One way you can keep it straight, the y-axis has the long line, and so it continues down. Now we have points, or also called ordered pairs, same thing, are written in the form horizontal coordinate and vertical coordinate, or another way to think of it is the x-coordinate and the y-coordinate. Okay, so let's look. We have our different quadrants here. So quadrant 1 is on the right, and then we're going to work counterclockwise. So we've got quadrant 1 here, quadrant 2, quadrant 3, quadrant 4. You could also have a point if it's on an axis. You can just call it on the x-axis. Similarly, if it's on the y-axis, you can just call that on the y-axis. Okay? Next, and you could also call, if a point is at the point 0, 0, you would just say origin. So some points you're going to be asked to say, where is this point? Is it in one of the quadrants, or you might have to say one of the axes or the origin. So you actually have 7 choices there to say. So we'll look at some of these on this one. So first we have the point -1, 3. Now this might look simple, but just make sure to take your time. So -1, 3, I'm going -1 for the x value, +3 for the y. So I'll have a point right there. B, I'll be at -3, -4, so right here. C, I'll be at +5, 1, 2, 5, that's right, and -1, so right there. So there's C, A, B, is that A? Oops, it's making me scroll in. And then D, darn it, I don't know what that point was going to be. I'll have to exit drawing. -5, 0. So we'll just draw those real quick again. So we had -1, 3. We had -3, -4. C was 5, 1, 2, 3, 4, 5, -1. And then -5 and 0 for y. So that's our point. So if we looked at each of these, we can see point A, so -1, 3 is going to be in quadrant 2. So I'll just put 2 down here. Usually you would want to write quadrant 2, but just because it's kind of hard writing on the screen, I'm going to leave it at that. -3, -4, so B is going to be quadrant 3. 5, -1 is going to be quadrant 4. And then -5, 0, notice it's not in either of the quadrants here. It's actually on the x-axis. And so that's what we would say for this one. Okay, all right. Let's look at the next ones. So we want to determine the coordinates of the plotted points on the graph below. So we have for A, it looks like I'm going 0 for x and 4 for y. So the point would be 0, 4. Okay, so we'll have first 0, 4. Sorry about the last little second. B will have 4 for x and 2 for y. So 4 and 2. C will have, let's see, 1 for x, and it looks like 1.5 or 1.5, or you could even put 3/2 for y. So 1 for x, and we'll just say 1.5 here. Okay, D will have -2 for x and 2 for y. E will have -2 and then -4. And then F will have 5, -4. So just make sure you're careful. Hopefully it's a little easier for you to write when you do it than it is for me. So you can just think about the points and not trying to write the points nice. So x coordinate first, y coordinate second. So for this section, we need to determine the quadrant for a given ordered pair, which is the same as a point. So notice how these axes are cut up into 4 sections. So we've got our 4 quadrants like we talked about that go counterclockwise. So if you see the point 2, 3 goes right 2 up 3, so that's in quadrant 1. 3, -2, so right 3 down 2, we're going to be in quadrant 4. D, you can see from the solution it's on the x-axis, and then 0, -4 is going to be 0 for x, so it'll be on the y-axis. Okay. All right, let's look at this next section. So we have a linear equation in 2 variables is an equation that can be written in the standard form ax plus by equals c. So a, b, and c are real numbers, but a and b are not both 0. Okay, so these are equations kind of like in these examples below, the x plus y equals 11 and 4x plus y equals 12. So we talked about this before, but this is how you can check if a point is a solution. And so what that means is if you have a line, so let's say we have our graph, we have a line, what they're saying is this point a line or a point the line passes through? Or is it a point off the graph? Okay. All right. And you can see when they put it in, it didn't come out as true. And so that tells us -5, 6 is not a solution. Okay, so we're going to just look at 2 of these points. We want to look first, is -1/4, 13 a solution to the system? Notice -1/4 is in the x spot, 13 is in the y spot, and so we'll substitute these in. So 4 times a -1/4 plus 13 equals 12. Oops. Loves doing that little scrolling thing. Okay, so I love this because the 4s will cancel each other out. It's like we have 4 over 1, so we're just going to cross cancel. We end up with -1 plus 13 equals 12. Oops, scrolling in some more. Let's go back. So -1 plus 13 equals 12, which we can see is true. -1 plus 13 is 12. It does equal 12, and so that checks out. I'm going to leave the other 2 for you to go through. So if it comes out like it did in example 4, 1 does not equal 11, that tells us it's not a solution. When it comes out true, like it did in example 5 part A, we can see, yes, this is a solution. So yes, just having a hard time writing here. So yes, this one is a solution. Okay, example 6, we need to find the missing coordinate to complete the following ordered pair solution. So basically it's like we know that x equals 2 and we want to find out what does y equal when x equals 2. So I'm going to come and do this. Oh, in fact, these ones are done for you. So 6 times 2 plus 5, we end up with a 217. Okay, next, this one is completed for you. We have -7 for y, and we can see x ended up being a -2. So we'll put that there. And those were also calculated, so I will leave those. Let's go to example 7. So we can see in this one, x equals 1. And so we're going to put 1 in for x here. So 4 times 1 minus 3y equals 1. We solve, so we get 4 minus 3y equals 1. Subtract 4 on both sides. Those cancel. We're left with a negative 3y equals 1 minus 4, which is negative 3. Divide by negative 3 on both sides, and so we end up with y equals 1. Now, if we wanted to check that, we could put both of those in. We'd get 4 minus 3 does equal 1, so we could see that those both check out so that this is actually the correct solution. Okay, let's do the same thing on the second one. So we have this time x equals 1/2, and we want to solve for y at that x value. So we have 4 times 1/2 minus 3y equals 1. So 4 times 1/2, we can cross cancel. 4 and 2 cancel, leaving me with just 2 minus 3y equals 1. We subtract 2 from both sides, and we end up with negative 3y equals 1 minus 2, or negative 1. Divide by negative 3 on both sides, so the final answer would be 1/3. And again, we could substitute this in and make sure that these points come out as true. Okay, let's look at example 8. Find the missing coordinates to complete the following ordered pair solution to the equation. So the first one, well, this one's different. We had x values before, now we have a y value of 0. I love this because we know when 0 gets put in, it's just going to multiply and cancel. So I have 5x minus 2 times 0 equals 10. Well, that term is just going to be gone because anything times 0 is just 0. So we end up with just 5x equals 10, divide by 5, and so x equals 2. So we have that point. Okay, let's do negative 2. This one is an x value. So put in negative 2 for x, minus 2y equals 10. So negative 10 minus 2y equals 10. We add 10 to both sides. End up with 20 equals negative 2y. Oops, running out of space here. Divide by negative 2, so y equals a negative 10. Okay? And again, you can always check these, put these in, and make sure they come out when you put the x and the y value, that this equation comes out true. Okay, the last one, we have x equals 0. This is another one that will work out really nice. So we have 5 times 0 minus 2y equals 10. Again, that term's just going to cancel because it's 0. We want to hold on to that negative in front of 2y. So negative 2y equals 10. Divide by negative 2 on both sides. So y equals then a negative 5.